Okay, welcome. In this video, we're going to have some learning targets to cover. We're going to make and interpret bar graphs and mosaic plots for categorical data. We're going to use bar graphs and mosaic plots to compare distributions of categorical data. And then we're going to describe the nature and association between two categorical variables. That's what we're doing in this video. Okay, in this lesson, we're going to talk about a school who's trying to pick a mascot. The principal decided to have students and teachers vote between three choices: Rams, Falcons, or Prairie Dogs. He took a random sample of students and a random sample of teachers. The results of the survey are given in the table. All right, so notice how it's in percentages, so it would be a relative distribution. We have teachers and students, and it wants us to create two separate bar graphs to kind of display the results. All right, so since we're doing separately teachers and students, right, we're not considering both of the variables. We're only considering one. In other words, we're just looking at one row for each time. We're looking at teachers and then students. So this would be called a conditional distribution. Remember, conditional is when you know a condition. So in this case, we already know we're teaching teachers separately and students. So we're kind of assuming in the first one that they're teachers, and in the second one we're assuming that they're students, instead of looking both at the same time. So that's why it's conditional distribution. So they want us to make first a side-by-side graph. We already have the percentages. So Rams I'm going to do in blue, and it's 80%. So their bar graph should look something like, do a little neater than that. Let's go up here, something like this. Right, that's Rams for teachers. We have Falcons, which was 10%. So Falcons goes kind of like there. Then we have Prairie Dogs, which is also 10%. So Prairie Dogs would be the same height. There. Okay, and then for students, you're going to do the same thing. So for students, it was 30% Rams. It was 60% Falcons. And it was 10% Prairie Dogs. So we're kind of here. Prairie Dog seems like it would be a bad mascot name, my personal opinion. Okay, so these are side-by-side bar graphs. So these are just called bar graphs. You can call them side-by-side graphs or just bar graphs. And the other thing they want us to do is they want us to make a segmented bar graph, which is essentially, remember, just a bar graph that's, instead of side-by-side, they're stacked onto each other. So for teachers, we're going to go 80% here. Do a little meter. So we got 80% Falcons. We have 80% Rams, 10% Falcons. So it should be right here. And then we have 10% Prairie Dogs. Remember, a segmented bar graph the stack should always include 100%. Okay, and then for students, we have 30% 30% Rams. Sorry, I don't know if I misspoke on the last one. The blue is Rams, right? Red is Falcons, and purple is Prairie Dogs. So we got 30% Rams. Give or take right there. We have 60% Falcons. So it'll be 30 to 90. And then we have 10%. 10% prairie dogs. Okay. So I made the width of this one just by drawing it a little bigger than that one. Imagine that they're the same width. Okay? Imagine they're the same width. They should be the same width. Okay, so the first question asks us, according to your display, which mascot appears to have the most support and why? Okay, so if you could imagine stacking both of the blue ones on top of each other, both of the red ones on top of each other, and both of the purple ones on top of each other, that would kind of be like a segmented bar chart of both teachers and students. And whichever one had the highest bar would be the highest. And you can kind of tell that's blue, right? So even though this one is bigger than that one, it's not as much bigger as this one is to that one. So if I stack the blue ones on top of each other, it would be higher than the red ones. So it seems like blue stands for Rams. So it seems like, according to the display, Rams is the most supported mascot, and that's because the combined student and teacher bars for Rams is bigger than the combined bar graphs of Falcons and what's the other one? Prairie dogs. Okay, so essentially if we stacked, if you imagine stacking the colors on top of each other and kind of comparing, blue would be the highest, and blue represents Rams. But there was a little bit of an issue because upon hearing the results of the surveys, the students argued that the decision was incorrect because 100 teachers had been surveyed, but 500 students had been surveyed. So they surveyed 100 teachers, but 500 students. So let's actually use this information to figure out, instead of the percentages, the counts or the number of responses for each. So since there's 100 total teachers, the percentages for teachers will be really easy to find because 80% of 100 is 80, 10% of 100 is 10, and 10% of 100 is 10, right? So in order to find the percents, remember, we take 80%, which means 80 over 100, and we multiply it by 100. So the hundreds would just cancel, and you would just get 80. And you would do the same thing for 10 and 10, right? So for teachers, it looks like the total counts were 80 said Rams, 10 said Falcons, 10 said Prairie Dogs. And the total would obviously be 100 because we surveyed 100 teachers. Now for students, it's 500 students. So in order to find 30% of 500, I have to say 30 over 100 times 500. Right? So this would be, the hundreds would cancel, and I would just get 5. 5 times 30 is 150. Right? And if I do that for 60, so it would be 60 over 100 times 500. right? So once again, the 5's cancel. So it would be 60 times 5, which is 300. Right? And then I could also do, the last one would be, what was it? 10%. 10% of 500, well, it would be 10 over 100. That's what 10% is. Times 500, which would be 50. Okay, so we have the total counts. Notice that these ones add up to 500 as they're supposed to, since we surveyed 500 students. So now we have the counts. So is there any way that we could adjust the graph to kind of to have a representation, a visual representation that we sampled more students than teachers, essentially? And how much more students than teachers did we sample? Well, if we sampled 100 teachers and 500 students, then the students we sampled is 5 times larger than the teachers, right? So we would want this graph to represent, to be 5 times wider than this graph, right? So how we account for different samples is called a mosaic plot. And so all we're going to do is we're going to make the width of these bars 5 times wider than the width of the other bars. Maybe I'm just going to, real quick, I'm just going to redraw this one. So the width should be the same. So I should have just done it at the beginning. So I will try to make it a little bit better of a graph to illustrate. So that's 80%. Now this one's kind of thinner now. Imagine it's the same size. Falcon 10%. And then prairie dog 10%. Okay, so that's a little better. All right, so if we wanted to represent that the students we sampled is 5 times more than the teachers we sampled, well, what we could do is let's just draw the same thing 4 more times, right? So that it's 5 times the other one, right? So I'm going to try to, I wonder if I can copy. Let me see. Okay, no big deal. I'll just draw it 5 times. So here's 1, 2, 3, 4. And 1, 2, 3, 4. And then 1, 3, 4, 5. Okay, so something like that. Okay, so imagine that the width of each of these boxes is exactly the same, right? So the way that we incorporate that is just add 4 more groups, essentially, right? So we're going to add 4 more students, student bars. So there are 5 total. In contrast to teachers' bars, which will only have 1 teacher bar. Okay, so if we want to incorporate the sample size, right, we just make the one with the bigger sample wider, right? And when we include the sample size, this would be called this right here. This is a mosaic plot. So a mosaic plot takes into account the actual size of the sample. Okay, So now we have the data. What should the EK mascot be? Well, let's do the totals. Now instead of percentages, we have the total amount of votes. So let's just add up the totals. So 150 plus 80, well, that would be 230, right? 10 plus 300 is 310. 10 plus 50 is 60. So we see that the actual one that got the most votes was Falcons, right? So the Falcons, right, it received the most votes. And those votes count were 310. Okay. Another way of saying that is the area of the Mosaic plot for Falcons is the largest, right? So since the area is the largest and Mosaic plots represent the sample size, you could look just visually that Falcons or students was a bigger sample than Falcons. And now if you combined all of the bars, the red bars would be the highest. So let's talk about the most important aspects of this video. Okay, so our learning targets 1 and 2 was all about displaying categorical data. And the key things you need to know is the bar graph, and what the bar graph does is each bar represents the frequency. It's the frequency. Remember, frequency is just counts, so how many people did each mascot, or it could be relative frequency, which is percentages. What percentages of the total counts chose each mascot, right? And that's for each category. Okay, so that's the first one, bar graph. The second one is a segmented bar graph. And that one is just stacked bar graph. So instead of side by side, we have a segmented graph where they're stacked on top of each other. And then the new one is the Mosaic plot, right? And a Mosaic plot is just a segmented bar graph. So it's still stacked on top of each other, but the width represents sample size. Another way of saying that is the width of the bars is actually proportional to the group size. Okay, so that was our first learning target. The second one is association. So association. How do I know that two things are associated or that one thing is causing the other? Association. Well, this is learning target 3, by the way. So if knowing the value of one variable helps us to predict the other value or the other variable, then the bar graphs will be different, right? If these bar graphs were the same, there would be no association between the variables. Since they're different, there is. So if knowing the value helps us predict, right? So if knowing the value of one variable if that helps us predict the value of the other variable, then the segmented bar graph will be different. If there's no association, then they'll be the same. Okay, so as long as the bar graphs, the segmented bar graphs are different, there's association. If they are the same, there's no association, meaning we can't use one thing to predict the other. Okay, so let's do some exercises. I would advise trying to pause these and do these on your own and then use the video to kind of check. Okay, so the following table gives the results of a random sample of upper-level students at Rocky Vista University, the Fighting Prairie Logs, along with the Mosaic plot. They asked juniors and seniors, and the results are below. We would need to calculate the proportions of juniors. They want all that are currently working, not working but have had a job, and also never had a job. So we need to do all three. Okay, so we're going to say, okay, this is juniors. Let's first find the ones that are currently working. So how many juniors are currently working? Well, that would be 14, right? And this is a conditional because we're already assuming they're juniors, so we're not going to consider seniors at all, just juniors. So how many total juniors was there? Well, 14 plus 22, 36, plus 15 is 51. So there's 51 juniors. So that means the proportion of juniors that are currently working, so we'll say currently working, oh, I left out the ly, the ones that are currently working is 14 over 51. Put that in your calculator and multiply, you would get 0.27. You can think about that like 27%, 0.27. If you wanted to make it a percent, you could multiply by 100. It's asking you the proportion, so usually they're going to want a decimal. If they wanted a percentage, they would ask you what percentage of students. So proportion means decimal. Okay, and then let's find the ones that are not currently working but have had a job. Not working, but have had a job. Again, we're just looking at juniors, so this is a conditional frequency, and that would be 22 out of 51. Put that in your calculator, and you would get 0.43, or 43%, if you wanted to make it a percent. And then lastly, never had a job. Well, the ones that never had a job would be 15 out of 51. Plug that in your calculator, and you get 0.29. 29%. Now let's do seniors. So it's a conditional frequency again. And so how many seniors are there? There's 80 seniors. So currently working, well, that would be 30 out of 80, which is, put that in your calculator, you get 0.38%. I shouldn't say percent, 0.38 or 38%. Not working, but have had a job. Well, that would be 40 out of 80, which is 0.50. And then never had a job. That's 10 out of 80, which is 10%, or point. Oh wait, that wouldn't be. It'd be 0.13. I think I need it over 10. Okay. So they want us to write a few sentences summarizing what the display in the Mosaic plot reveals about the association between grade level and job experience for students. Okay, so are the bar graphs the same? We know we sampled more seniors than juniors, so that's why it's a mosaic plot, which is why the width of seniors is bigger than the width of juniors. And the bars aren't the same. Like, it looks like more seniors, for example, we're currently working, as well as more seniors are not currently working but have had a job than juniors. So there is an association because the graphs aren't the same. So there is an association between grade level, whether you're a junior or a senior. So between grade level and job experience. Okay, so there is an association. The bar graphs are not the same. That means that if I know the grade level, then I can predict or at least helps us predict their job experience. Okay. Let's do an example. So for example, seniors are much more likely to be currently working. Than juniors, right? And if you wanted to put the exact numbers, well, we have those numbers. We have 0.38 versus 0.27. Okay, so that concludes this video on Mosaic.